Hello everyone, welcome to MK Academic Solutions. So in this video, I am going to explain you about the equilibrium constant expression for the different type of heterogeneous type of reactions. So in the last video, I have explained you homogeneous gas equilibrium, and in this video, I am going to cover the heterogeneous equilibriums and their rate constant expression. Okay, now let us start our session now. So first case 5 we are going to discuss So case 4 we are going to discuss. In the last video I have explained you up to case 3. So in the case 3, up to case 3 I took homogeneous gas equilibrium where n is equal to 0, where n is less than 0 and where n is greater than 0, delta n is greater than 0. Now this is the homogeneous liquid system for ethyl acetate. Homogeneous liquid system. For homogeneous liquid system, how we are going to write the Kc expression? So here, for this Kc, how will write Kc is equal to simply product concentration of product by concentration of reactant raised to their power stoichiometric coefficient. Okay. So now CH3 COO C2H5 power 1 into H2O power 1 by CH3 COOH and C2H5 OH. So this is the way of expressing the equilibrium constant. See here also power 1 and here what is the delta n value? Here we get Kc is equal to, so here delta n, what is the delta n here? Number of moles of products minus number of moles of reactants. So here 1 and 1 2, total 2 minus 1 and 1 2, that is equal to 0. Delta n is equal to 0. So here there is no units for the Kc. So if delta n equal to 0, there is no units for Kc. We know Kc units are what? Moles per liter to the power delta n. So here delta n equal to 0. Moles per liter to the power 0. Anything power 0 is equal to 1. Means there is no units for the Kc. No units for Kc. Okay, so this is about the homogeneous liquid system. Next, take case 5, heterogeneous equilibriums. Now we are going to discuss about the heterogeneous equilibriums. Okay, so now what is the Kc and Kp expression here? We'll see. So heterogeneous equilibrium, first of all, what is the meaning of heterogeneous equilibrium? We know that is, if the reactants and products are not present in the same physical state. So if the reactants and products are not present in the same physical state, that is known as what? Heterogeneous equilibrium. See, for example, this is present in the solid state, it is also present in the solid state, but it is present in where? In the gaseous state. It is also present in the gaseous state. Okay, so now here, what is the meaning of heterogeneous equilibrium? If the reactants and products are not present in the same physical state, that is known as heterogeneous equilibrium. Therefore, for this one, Kc, how we are going to write the Kc? Kc is equal to H2O gas into CO2 gas. H2O gas into CO2 gas. Right, H2O and CO2, and here we are not at all going to take the concentration of Na2CO3 as well as sodium bicarbonate. Why we are not going to take the concentration of Na2CO3 and sodium bicarbonate, means children, here these are present in the solid state. The molar concentration of pure solids is become unity. That's why we are not at all going to take. their molar concentration will become unity, means 1, means their concentration not at all going to change along with the volume. That's why we are not at all going to take their concentrations. Okay, this is. So now these are the units of Kc. So here, even if you write also, for example, here we are going to write Na2CO3 by NaHCO3, NaHCO3 square. Also if you write, so as it is solid, its concentration will become unity, H2O and CO2. So here unity means one we are going to take Na2CO3 concentration, one we are going to take, and NaHCO3 concentration also we are going to take as 1. We are going to take as the 1. So the finally it will become Kc is equal to H2O and CO2, H2O and CO2. So now what are the units of Kc here? Kc units. So here what is the delta n is equal to, here delta n is equal to 2. So here power 1 or else simply number of moles of gas, here 1 and here 1, and here there is no gases are in the aqueous solutions. That's why here delta n is equal to 2. Therefore Kc is equal to moles per liter, to the power 2. Therefore moles square liter power minus 2, moles square liter power minus 2. So this is the expression for the Kc and Kp. So how we are going to write the Kp? So Kp is equal to, how we will write, partial pressure of CO2 into partial pressure of H2O, partial pressure of CO2 and partial pressure of CO2. So here what are the units of Kp? Kp is equal to atmosphere to the power delta n. So therefore Kp is equal to atm square, as delta n is equal to 2. So now relation between Kp and Kc. So we know Kp is equal to Kc into RT to the power delta n. Therefore Kp equal to Kc into RT whole square. So this is the relation here between the Kp and Kc. So for this case, next we see some more reactions. Okay, decomposition of calcium carbonate. Decomposition of calcium carbonate is also one of the example of what? Heterogeneous system. See, for this how we write the Kc? Kc simply how we will write? Only this is calcium oxide also present in the solid state. Only CO2. Kc is equal to CO2 power 1 and Kp is equal to partial pressure of CO2. Okay. So here what are the units of Kc? Kc units are what? Moles per liter, power 1 only, and Kp units are what? What will get Kp units? Atmosphere to the power 1, atmosphere, or simply we can take as the atmosphere. Okay, right. Next, relation between Kp and Kc. Relation between Kp and Kc. So here Kp is equal to Kc into RT to the power 1. This is the relation. Why? Because here delta n value is equal to 1. Next, the reaction between steam on heated iron. Steam on heated iron. So this is the H2O gas. It is known as what? Steam. And the steam is going to react with iron as the following reaction here. So now here what is the Kc? So this is also reversible reaction only. Reaction of steam on the heated iron also reversible reaction. So here what is the Kc here we will get? So here H2 in the presence in the gaseous state, H2O is present in the gaseous state. and here Fe3O4 and Fe are present in the solid state. So that's why we are going to take H2 gas and H2O gas in the Kc expression. So what is the product here? H2 to the power 4 by H2O to the power 4. Okay, so now here what are the units of Kc here? Kc is equal to moles per liter to the power delta n. So here what is the delta n value? Here you will get delta n is equal to number of moles of gases products 4 and this is 4 minus 4 that equal to 0. So 0 you will get there. Therefore Kc is equal to moles per liter to the power 0, that is equal to 1, means no units here. Next Kp is equal to, what is the Kp expression here? So here Kp is equal to what? Partial pressure of H2O to the power 4 by, sorry, not partial pressure of H2, partial pressure of H2 partial pressure of H2 to the power 4 by partial pressure of H2O to the power 4. So this is the Kp expression. And here what are the units of Kp? Kp units. Kp is equal to atmosphere to the power delta n. So here as delta n is equal to 0, here Kp is equal to 1 means no units. Simply you take no units. So now when delta n equal to 0, Kp is equal to Kc. So here Kp equal to Kc. This is the relation between the Kp and Kc. We already know when delta n is equal to 0, there is no difference between the Kp and Kc. Right. Next, reaction of steam on heated carbon. Reaction of steam. This is the steam reaction and it is going to react with the carbon. So H2O in the gas state is known as what? Steam, and it is going to react with the carbon in the solid state. So this is the reaction of steam on the heated carbon. So what we are going to get? CO2 gas and hydrogen gas. This is the gas, hydrogen gas, carbon monoxide gas and water is present in the gaseous state. Okay, this we are going to get. Okay, right. Now we will see Kc expression first. Kc. So how we write the Kc? CO present in the gaseous state, CO and H2. First product we need to write. First what we need to write? Product. Concentration of product rise to their power stoichiometric coefficient. So here there is no stoichiometric coefficient. So means nothing is there, means 1 we will write by H2O in the gaseous state power 1. Okay, so this is the Kc expression and Kp expression. Okay, Kp expression. What is the Kp expression? Simply partial pressure of CO into partial pressure of H2. Partial pressure of CO into partial pressure of H2 by partial pressure of H2O. Partial pressure of what? H2O. Right. Now units. Units you will see. What are the units of Kc? So here what is the delta n value? Before seeing the units, first we need to see the delta n value. What is the delta n value? Here you will get 1 plus 1 2, 2 minus 1 1. So Kc units what will get? To moles per liter to the power delta n. So here delta n is equal to 1. Therefore units are what? Moles per liter. Next Kp units. So Kp units is simply atmosphere. Relation between Kp and Kc. Kp and Kc, that is Kp is equal to Kc into RT to the power 1. Why? Because delta N is equal to 1 here. Next, dissociation of ammonium carbonate. So this is the ammonium carbonate. It is present in the solid state and it gives us ammonia gas and carbon dioxide gas. So for this, what is the Kc expression here? Kc is equal to NH3 square and CO2 gas. NH3 square ammonia gas square into CO2 gas by ammonium carbonate. But ammonium carbonate is what? It is present in the solid state. So when it is present in the solid state, no need to write in the Kc expression. Okay. So this is what Kc expression. Right, children. Next, Kp expression. What is the Kp expression here? You see, Kp. Kp is equal to partial pressure of NH3. Partial pressure of NH3 square and into partial pressure of CO2. Partial pressure of CO2. Next, units. What are the units of Kc and Kp? So here Kc units are what? Kc is equal to moles per liter to the power delta N. So here what is the delta N value? What is the delta N value here? So 1 plus 2, 3, and here these are present in the solid state. Total delta N value is equal to 3 only. 3 minus 0 means here delta N is equal to 3 moles of products are there, but here 1 mole of reactant is present, but that is present in the solid state, so no need to consider. So 3 minus 0, therefore delta N is equal to 3. So now here Kc units what will get? Moles per liter whole to the power whole cube, or else simply mole cube liter power minus 3. And Kp units, what are the Kp units? Atmosphere to the power delta N, that is equal to atmosphere cube. Relation, we will see the relation we know. Kp is equal to Kc into RT to the power delta N. So here what is the delta N value? Simply here delta N. Therefore delta N we know, that is Kp equal to Kc into RT to the cube, RT to the power 3. Okay, this is about the expression of equilibrium constant Kc and Kp and units of Kc and Kp, relation between Kc and Kp for some reactions. Okay, now okay, so with this I am going to end this video. So this is one short video. So this video is useful for you how to write the Kc and Kp for the different type of reactions. Okay, thank you for watching and all the best.